Hey there awesome student, welcome back to Bhanzu classes. I am super excited to have one more session with you. Are you excited? So we are about to have blast together once again. Okay, so I really want to know if you have gone through the previous video or not. Tell me, do you remember what rational numbers are? Something that can be represented in the form of P over Q. Q should not be 0. Then we spoke about addition, subtraction, multiplication and division of rational numbers. Then we spoke about closure property. In closure property, what did we learn? Rational numbers are closed under addition, subtraction and multiplication, but not under division. So now I have a quick question for you to think of. And the question is, you have 3 ropes. The first rope is 3 over 4 meter long. Second one is 2 over 3 meter long and the third one is 1 over 2 meter long. What if you attach the first 2 ropes together and then attach the third one? Will the total length be same if you do it in a different way, that is attaching the second and third rope first and then attaching the first one? What do you think? To answer this question, we are going to learn one of the interesting mathematical concept. Okay, so what is that? Let's quickly get a mastery over it. We are going to talk about commutativity and associativity for rational numbers. Okay, now we are going to talk about these two properties, but first of all let's talk about the commutative property. Now we need to check what commutative property is first of all. In commutative property, even if you change the order of numbers while performing the operation, the answer should be same. Okay, let's quickly check with the whole numbers. Is 3 plus 4 same as 4 plus 3? Yes. So here we can say that addition is commutative. Now what about subtraction? Is 3 minus 4 same as 4 minus 3? No. So this is not same. Now what about multiplication? Is 3 multiplied 4 same as 4 multiplied by 3? Yes. Is 3 divided by 4 same as 4 divided by 3? No. So division is not commutative. Let's quickly check with the integers also. What do you think? Is minus 3 plus 4 same as 4 plus minus 3? You can quickly write the question and try to solve it. Answer will be same. Okay. Now what about subtraction? What do you think? 4 minus minus 3, is it same as minus 3 minus 4? No, this is not going to be same. What about multiplication? Is minus 3 multiplied by minus 4 same as minus 4 multiplied by minus 3? Yes. And what about division? Is minus 4 divided by 3 same as 3 divided by minus 4? No. So this is what we have spoken about commutative property. The question that I just now said, you can even pause the video and you can quickly solve and check the answer. You will understand that. Okay. Now we are going to check what associative property is. In associative property, we can group the numbers in any order. The answer is going to be same whatever order you follow. Okay, let's quickly check with whole numbers. Let's say the question is 3 plus 4 plus 5. Okay, I'm writing it 2 times so that I can show you 2 groupings. Now, this is the first group and in the next one, this is the first group. If you do this calculation in 2 different ways, here you are solving this bracket first, here you are solving this bracket first. Do you think the answer is going to be same? Yes, it is going to be same. So, associative property holds true in case of addition. But does it hold true in case of subtraction? Do you think so? Let me write the question over here. And again, I will do the grouping in 2 different ways. Do you think the answer is going to be same for both of these calculations? No. Now what about multiplication? It is going to be same. You can multiply the numbers in any order, but in division, you cannot divide in any order. And you know what? Same goes with the integers. Integers can be added in any order. That doesn't matter. Okay, so it holds true over here. But in subtraction, you cannot subtract in any order. You can multiply in any order, but you cannot divide in any random order. So this is what we have recalled about commutative property and associative property. Okay, so now we are going to talk about commutative property for rational numbers. So now let me give you a question for addition first of all. Let's say the question is 2 over 5 plus 1 over 3. first of all, let's quickly take the LCM of 5 and 3, which is 15, right? So let's change the denominator to 15. So I will multiply the first fraction's numerator and denominator by 3. So this is going to be 6 over 15. In second fraction's case, I will multiply the numerator and denominator by 5. So this is going to be 5 over 15. The answer is going to be 11 over 15. Now what do you think? If I change the order, answer is going to be same or different? Let me quickly check. 1 over 3 plus 2 over 5. Now 5 over 15 plus 6 over 15. So this is also going to be 11 over 15. So here commutative property holds true for rational numbers also in case of addition. Now let's check with the subtraction. Okay, so I'm going to take the same fractions only. Let's say 2 over 5 minus 1 over 3. I know it's equivalent fractions. 6 over 15 minus 5 over 15, which is going to be 1 over 15. But if I change the order, then what is it going to be? Let me quickly show you. Minus 6 over 15. So this is minus 1 over 15. So what did we see over here? The answer is not same. So the subtraction is not commutative for rational numbers. So now quickly check with multiplication. For example, the question is 2 over 5 multiplied by 1 over 3. What is the answer? 2 over 15. If I change the order, will the answer be same? Let's check. So 2 times 1 is 2, 3 times 5 is 15. Again same. So it is commutative. Let me quickly show you with the division. Okay. Now 2 over 5 divided by 1 over 3. How will we solve it? 2 over 5, division will be changed to multiplication and 3 over 1. The answer is going to be 6 over 5. Now let's do it in a different order. Okay, this time this is going to be 1 over 3 times 5 over 2. So this is going to be 5 over 6. So answer in both the cases is different. So division is not commutative. Is that clear now? So let's quickly revise. Herein we saw addition is commutative, multiplication is commutative, but subtraction and division are not commutative. Okay. So now we are quickly going to practice few questions. It says verify the commutative property for addition and multiplication. Okay. Let's quickly verify then. Okay. Now let's say the question is minus 10 over 11 plus minus 8 over 33. LCM is going to be 33 over here for these two numbers. So I'm going to multiply the first fraction's numerator and denominator by 3. So here I'm going to get minus 30 over 33, then plus minus 8 over 33. Then what will happen? 33 at the bottom, then minus 30 minus 8, which is going to be minus 38 over 33. What if I change the order? Will the answer be same? Can we quickly check it? Okay, now let's say it is minus 8 over 33 plus minus 10 over 11, right? So minus 8 over 33 as it is. Now this is going to be minus 30 over 33, then 33 at the bottom, minus 8 minus 30, which is again going to be minus 38 over 33. Yes, champion, we saw that this is actually commutative, right? Now we will check the multiplication question also. Minus 10 over 11 multiplied by minus 8 over 33. Minus 10 multiplied by minus 8 is 80 over 11 times 33 is 363. And if you do it in a different order, then also the answer is going to be same. Okay, so we have verified it once again. Okay, so now we are going to learn about associative property. Okay, so in this, let's quickly get a mastery over addition first of all. Okay, associative property for rational numbers. Now, let's take the rational numbers. For example, 1 over 7 plus 2 over 7 plus 3 over 7. Okay, I'll do the groupings in two different ways. Fine. First of all, I'll do the grouping like this, and then I will write this question once again, and I will do the grouping over here, champion. Okay. Now this is going to be 3 over 7, then 3 over 7, then this is going to be 6 over 7, and if I see on the right hand side here 5 over 7, then here 1 over 7, then this is also going to be 6 over 7. So yes, this holds true for addition over here. It works in rational numbers also. Now I will check with the subtraction also. Okay, let's see it quickly. 1 over 7 minus 2 over 7 minus 3 over 7. Okay, so here I will do the grouping from here. Then I will write this question again and let's do the grouping over here. So let's solve the bracket first. I'm going to get minus 1 over 7. Then this is 1 over 7. This is minus. Let's keep it in bracket. And here what is going to happen? Minus 1 over 7 and then minus 3 over 7. Okay, here 7 at the bottom. Then 1 plus 1 is 2 over 7. And here what is going to happen? 7 here at the bottom. And I'm going to write minus 1, minus 3. So this is going to be minus 4 over 7. So answer in both the cases different. So we can say that this does not hold true for subtraction. Let me quickly move on to multiplication. 1 over 2 multiply 1 over 3 multiply by 1 over 6. Okay. Let me do the grouping over here first of all. Then here, let me do the grouping in a different way. Okay. 1 over multiply 1 over 3 is equals to 1 over 6. Multiply 1 over 6 is equal to 1 over 36. Here, I am going to do 1 over 2 multiply by 1 over 18 because I am solving the bracket. 3 times 6 is 18. So, answer is same. So, I can say that this holds true for multiplication. We can group it in any way. But in case of division, do you think so? Let's quickly check it. 1 over 2 divided by 1 over 3 divided by 1 over 6. Let's quickly check with this order first of all. 1 over 2 multiply by 3 over 1. Okay, let's quickly solve the bracket. What will it be? It is going to be 3 over 2. Then divided by 1 over 6 and then 3 over 2 multiply by 6 over 1. 2 times 1 is 2. 2 times 3 is 6. So this is going to be 9 over 1. Okay, now I am going to write it in a different way. Fine. So let's say it is 1 over 2 divided by 1 over 3 divided by 1 over 6. Let's do the grouping from here. 1 over 2 divided by, let me solve the bracket. So let's see what is it going to be. Okay, so this is going to be 6 over 3 and then 1 over 2 multiply by 3 over 6. Okay, and then this is going to be 3 times 1 is 3, 3 times 2 is 6. Answer is 1 over 4. Answer in both the cases is different. So this does not hold true for division. Is that clear to you now? So now let's quickly recall everything. Okay, so we learned that in addition and multiplication we can do the grouping in any order, but in subtraction and division we cannot. You can see that here we can see the sign of not equal to. So if we do the different kind of groupings, we are not gonna get the same answer. Okay, so now let's quickly revisit to the question that we discussed initially. Now it says that if you attach the first and second rope and then you attach the third one, is the answer going to be same? If you do it in a different way, that is second and third rope first and then attaching the first one, is the answer going to be same? Now you must be thinking, yes, this is because of which property? Associative property. Okay, so now we will practice the question, the interesting question. Okay, I really like this question. Hopefully you will also like it. So we are going to do the groupings over here. So what will I do? I will make the groups of this and this fraction and then I will make the group of this fraction and this fraction. And let me write this grouping in new way. Okay, 3 over 7 plus minus 8 over 21. Then the second grouping is minus 6 over 11 plus 5 over 22. Okay, I will put one more bracket here so that you can see that I have made two groups. Now LCM of 7 and 21 is 21, right? So I will multiply the numerator and denominator of first fraction by 3. So it is going to be 9 over 21 and then plus minus 8 over 21. Now let me see the second part of it. Okay, so in the second part I have minus 6 over 11 and I want the denominator to be 22 because that is the LCM of 11 and 22, right? So let's quickly change the first number and I want the denominator to be 22. So I will multiply it by 2, the numerator also by 2, the denominator also by 2. So this is going to be minus 12 over 22 plus 5 over 22. Okay, and now what to do? We can quickly solve it. Okay, this is going to be 9 minus 8 and then what is going to happen over here? Minus 12 plus 5 Okay, so here this is 1 over 21, this is minus 7 over 22. Now, I have 1 over 21 plus minus 7 over 22. So, can you quickly tell me what is the LCM of 21 and 22? That is 462. So, I want the denominator to be 462. For that, let me quickly change the first number. Okay. So, here I am going to multiply the numerator and denominator by 22. So, this is going to be 22 over 462. In the second rational number, what will I do? I will be multiplying the numerator and denominator by 21. This is going to be 147 over 462. Then 462 at the bottom. 22 minus 147. This is going to be minus 125 over 462. Was it easy? I really enjoyed this question. I hope you also did so. Okay, let's quickly summarize all of the things that we have learned. We learned about commutative property of rational numbers. Yes. What did we learn? Addition and multiplication are commutative, but subtraction and division are not for rational numbers. And then what about associative property? We can group the numbers in any order in case of addition and multiplication, but not in case of subtraction and division. Okay, but this is not enough. There are still some more fascinating properties to explore. Okay, stay tuned for the next video where we will dive into even more intriguing questions. Okay, so let's say goodbye to each other.